Alright, so this is the first diagram for chapter 4.3. This is me over here, Mr. Howell. And this is my friend Mr. Laidlaw over here. And here's the kite mess up at the top. So what we need to do is we need to find the distance in between me and Mr. Laidlaw. But first we need that top angle, either if we're using the sine law or the cosine law. Either way we need that top angle. Before we can get the top angle though, we need the angle x. So for angle x, what I do is I use the sine law, and I say that angle x is equal to the sine of 40 divided by 5. Remember that when we're doing this, you always look at the angle, or the side, right across from your angle. And that's what goes underneath on the bottom. So for angle 40, 5 is right across, so that's what goes on the bottom. And sine 40 over 5 is equal to sine of x, which I don't know, over 7.5, which I do know. If we work out the sine 40 divided by 5, we get 0.1286. If you don't get that, check your calculator to make sure that you get that. And that's equal to sine x over 7.5. To get rid of the 7.5 on the bottom, I have to multiply it by it. So it's multiply by 7.5, and I have to multiply both sides by 7.5. On the right side here, those cancel out. That's why I multiply by it. On the left side, I'm left with 0.9642 is equal to sine x. And then remember to solve for an angle. When we're solving for an angle, we have to use sine to the negative 1 of 0.9642. Sine to the negative 1. And on your calculator, that's the inverse, or the second, or the shift of sine. When I do that, I get an angle of 74.6 degrees. Again, if you don't get that, make sure that you can get that on your calculator. 74.6 degrees. Now that I have that for the top angle, I have to take 180, which we've seen before is the entire triangle, all the angles. I have to subtract off my 40 degrees, the bottom left. Then I have to subtract off 74.6 degrees, which is the bottom right. And that leaves me with 65.4 degrees. And that is the top angle right at the very top. 65.4 degrees. So now that I have the top angle, and I have at least one of the other ratios of the other two, angle and side, now I can again use the sine law to solve for the question mark. So for the question mark, it's going to be equal to, we're going to use sine 40 over 5 is equal to sine, this time I'm using my top angle. The reason I'm using my top angle is because I want the side right across from it. So I have sine of 65.4 divided by my question mark, which I don't know. When I solve for the left side, sine 40 over 5, I get 0.1286, like we saw before, same value, 0.1286, is equal to sine of 65.4 divided by question mark. And again, this is kind of the way I solve these. I switch the places of these two things. I switch the places. So I get the question mark is equal to sine of 65.4 divided by 0.1286. That means that my question mark should be equal to about 7.07 meters. And that's how far apart me and Mr. Laidlaw are.